Next is angular velocity. Angular velocity means velocity of the rotational motion. It is denoted by symbol omega. Angular velocity is equal to what? Angular displacement upon time taken. Angular displacement upon time taken, where we know theta is equal to what? S by r, so it is ds by dt into 1 by r. So we get v. This is what? This is the linear velocity, that is v upon r. ds by dt is what? Linear velocity. Linear velocity. And this omega is the angular velocity. So we get v equals to omega r. So this is relation between angular and linear velocity, where the unit of the angular velocity is radian per second, and unit of linear velocity is meter per second. Similarly, the next term is angular acceleration. Angular acceleration is denoted by a symbol of alpha, and this alpha is equals to angular velocity upon dt. Now if we substitute the value of angular velocity, that is v by r, we get dv by dt. This is what? This is linear acceleration A. This is linear acceleration. So again we get a relation that alpha is equals to a by r, So we get what here? A is equals to alpha r. So this is relation between linear and angular acceleration. Next term is, now before going that, we will do moment of inertia. Now what this term mean, moment of inertia? Just in linear motion we have mass. In rotational motion, instead of mass we have a term that is called I, moment of inertia. That is called moment of inertia. And this both terms are analogous to each other, means in linear motion mass, and in rotational motion moment of inertia. This both play the same role. So the value of this moment of inertia, suppose we have a rigid body, this is the axis of rotation. So the distance of first particle be r1 and it's making a circle of radius r1. Second of making a circle of radius r2, this is m2, and nth is making a radius of rn. So what the moment of inertia state? It is the product of mass and distance square, like this. If n particles are there, so this is the moment of inertia. So for the discrete system we can write it as summation of mi ri square, I varying from 1 to n. This is the formula for moment of inertia. So I is equals to